I will be talking about maintainability, which is a topic which is very often glossed over. You're just hand-waving when discussing maintainability. Oh yeah, this is maintainable, or that is not maintainable. What is it? I hope that we will explore it and have some discussion. I want to start off by saying that maintenance is a good thing. I think maintenance is one of the best things there is, actually. Very often we see companies wanting to outsource maintenance. They want to try and find a low-cost site of the own country or outside where they can drop off the maintenance. Oh, maintenance is not something we want to do for some reason. This is quite sad. Granted, maintenance is not the cool thing to do, perhaps. You're not working with virtual reality stuff, the new cutting edge when you're working with maintenance. It's actually better. Because when you're working with maintenance, you're working with the proof that someone cares about your product. It is proof that someone wants what you're doing. What you have done has meaning. Someone is paying for it. If it wasn't in maintenance, chances are your product is already dead. I think there's a lot of people here that can relate that have been working with large systems or large legacy systems that still are in maintenance. And that's where the good thing happens. That's where we have the magic. But let's digress and discuss about some of the etymology behind the word. The meaning of maintenance, this is the dictionary meaning, is to keep a building, machine or a road in working condition or in order by checking or repairing it regularly. This is just the same thing as spending effort in order to counteract entropy, right? Because everything is decaying. Even me, I am decaying right now, right here. I'm probably throwing off some particles or something is happening within me. My beard is getting grayer every moment. We don't see it right now. So everything is decaying. And this also pertains to software systems. Because we also have a definition of maintenance within software. So this is a more organic thing. Because maintenance starts happening the same moment when you have released your stuff and you make the first change. Because there are several changes in software that are called maintenance changes. You have adaptive changes, changes that you need to do to your software because the world around it is changing. For example, if you're working with finance systems, there could be new regulations on how to perform calculations. Then you need to perform an adaptive change. There could be perfective changes, such as Roger likes doing, that makes things quicker, makes it more perfective. Or also prescriptive changes that will improve something that's already there, but doesn't need to be perfect, but just some refactoring or redesign. All of this happens after the software has been released. But what is maintainability really? When is something maintainable? What does it mean that something is maintainable? We do have a sense, a gut feeling, that this is maintainable, this is not maintainable. If code looks horrible, we think this is unmaintainable for sure. But what is behind that? I think it boils down to that there's two important aspects. Maintainability is a time-dependent property of software and also a subjective measure. I don't think we will ever, unless we can model the human brain perfectly within computers, I don't think we can produce one program that can say this piece of software is maintainable by 0.5 according to a scale. Because there's a lot of psychology involved, a lot of history. So talk about the time-dependent property. Code that I just wrote is completely maintainable by me. I like to entertain that notion at least. By the coming seconds. I just knew why I wrote it. Sometimes I don't. I just know exactly what's the meaning of this code. And all that's very good that it's maintainable by me. But I'm not the only person in this world. I'm not Will Smith in this movie where he's alone and everyone is dead. Actually, what about tomorrow? Is it still maintainable? Because now we have the time aspect of it. What about 5 years from now? Is it still maintainable? I think it boils down to that we need to remember the what, the why, etc. Why I did the change, where I did it. And also you have the landscape. The landscape, the modularity of the system may look different. You have new source code names, new people working in the team. Part of the knowledge that was ingrained into the organization is gone. Someone that wrote that piece of software may be out of the company, they might even be dead. So there's a lot of things to consider in the time aspect. Then we have the effort. There is effort involved, I think. I claim, and these are my own wild claims with, of course, some substance in reality by actual work, is that maintainability is coupled to effort. How easy it is to make a change. How easy it is. Because it is about cognitive effort. That is why we're working with software, because we like using our minds. Software work is a highly intellectual work. Comprehension is imperative in order to successfully work on software systems. And we can bind this to a work by Meir M. Lehman, which I might be mispronouncing his name, but we will see his name written very soon, so someone can correct me perhaps, that has been doing a very substantial work on analysis of large systems that are in maintenance. He's been doing a lot of work on maintainability. And there are 6 laws that he has proposed that are valid for what he calls EType systems. There are 3 types of systems. S-types, that are static systems, which are fully specified from the start to the beginning, from beginning to end. Such examples would be a calculator. It is very exact how those works. Then there are P-type systems that are practical systems in which you need to iterate a bit, but you can still fully specify them, how they are supposed to look at when they are done. Example of such a system in real life would be if you are a witness and you have a sketch artist helping you to iterate to find the face of the perpetrator. That would be such a system that you iterate. You get feedback by the previous result. And these laws that I will be mentioning, that are the work of Lehman, is valid for E-type systems, embedded systems, systems that become part of reality of our world, systems that become part of what we're working with. I think most of us are working with that kind of systems, where you start relying on that system. And because you're relying on it, and that system takes input from the real world, it's very organic. It has to change, because reality changes. And for those kind of systems, there are some very interesting aspects. And you need to comprehend them if you want to make changes without breaking them. And that needed effort is proportional to the complexity of the system we wish to comprehend. In other words, if something is simple, you're probably going to understand it pretty quick. If it's very complex, you will have to grind your head against it for a while. As a result of that, complex solutions require more cognitive effort to comprehend. So if you have a solution that is simple, you can understand it quickly. If you have a complex solution, it's going to take a while for others to understand it. Does that mean that it's cool to work with complex solutions and complexity? No. I've had these discussions at work that, yeah, we're working with telecom-grade systems, extremely complex. I'm proud of that. That's nothing to be proud about, to work with something that's complex. To me, if I produce complexity, I have failed, because I want to keep things simple. I want to work smarter. I don't want to work harder. I don't want to have to put in more hours. I want to reduce. I want to boil things down. I want to distill. I want to take something complex and show my genius by producing a compact, clear glass castle that I can show someone. Look at this. This is exactly what you wanted, but I've been working on this for a while. Because complexity is the enemy. Complexity is not something we want, because complexity incurs cost, cognitive cost, which makes something hard to maintain. I think it's extremely important that we use the right language and the right tools. I could choose to write a web server using assembly for the x86 architecture. That's certainly going to be complex. It's going to be a hard work, a lot of work. Or I could use something else, something that allows me to abstract from the details I don't need to look at. For example, Python or APL. That would be the right tool for the right job. Some of you might know about Kolmogorov complexity, which is coupled to how much information you need to represent something. And that's coupled to complexity. Using the right tool, you can express something very complex very simply. And this is, once again, I think this is our role. I think it's the role of the engineer is to find the simple solutions, is to distill complexity, because that gives maintainability. There is another thing which we are victims of, and it's software decay, also called software entropy. And this way we see the name Meyer and Lehmann. I want you to please write that down or whatever you want to do, but remember his name, because he's been doing a lot of work since the 80s analyzing very large systems. He has a very good group that does a lot of work on this. And out of this work, we find what is called the software evolution. It's a new term, where you look at software in a different way, compared to, in contrast to waterfall, where you have clearly defined that now the software is done, it is delivered. Nothing more is supposed to happen to it. In the software evolution mindset, software is never really done. It's just released. Because it will evolve. It will be used. In time when users use them, they will realize how they want it to be. The users are realizing how they want to shape your piece of clay that you have given them. That's the new mindset. Software entropy will always increase for every change unless effort is made to reduce it. And this is a consequence of one of the laws. Something that is used will be modified. This is true for EType systems. And when it is modified, its complexity will increase, provided that you do not do anything against that. This can be measured by the amount of function points in the systems, the amount of anything you like, branching, etc. And let me mention just two interesting. I threw this in just because I want to talk a little bit about that. Coupling is when you have dependency in between things. And you can increase software entropy by increasing coupling, so things start depending a lot more on each other. That's one way. Coupling is generally considered a negative thing, that you have a high dependency, because then it's hard to change one part without changing the other. Cohesion is generally considered a good thing, logical cohesion. Things that belong together logically should be belonging together or closely together in the code. If I have one system and it gets in data, and that data is supposed to be used in two places, then those two places, if they are logically far apart, they shouldn't be close in the code. It should be separation in there. But what usually happens when software entropy starts to set in is that everything starts to depend on everything everywhere. You had a pristine data flow. This is the flow of the program. You can even visualize it. And then suddenly you start creating out branches. I need this data down here as well. And you create a data flow down there. And you realize, oh, the same data is needed over here. And you start duplicating the data. And very soon you have a lot of data streams within your programs. And it's very hard to see how to structure that in the proper way. That is when logical cohesion is being crippling. This is also coupled to economics. So I've just said that maintainability is a time-dependent property. It's very dependent on the now. It's the proximity in time. And it's also a hint of how easy it is to make a change. So I'm saying that it is coupled to complexity. Complex solutions are hard to maintain. Simple solutions are easy to maintain. And I think that we should make a lot of effort of maintaining things in a simple way. And we've talked about software entropy. What is the cause behind deterioration that increases complexity? Because every time you change the program, you will make it more complex, and you need to take efforts to counteract that. Typical efforts are re-architecturing or refactoring, having a sit down in the group and discussing, you know what, I added this new functionality and perhaps we should do something about the general structure. Maintainability is also coupled to economics. There is something called the cost of change, COC. In a project that has been living for a long while, the cost of change tends to go up. In the beginning, when the project is pristine, it's vanilla, it's greenfield, making any change is very easy. As the project lives and the product grows, gets more and more features, making the same small change starts to become more and more expensive. This is the cost of change increasing. This happens because the system has been victim of entropy, software entropy. On architectural level, it wasn't architected in a way that was made to facilitate changes, and it wasn't re-architected when it should have been. There is not one architecture that will stand the test of time forever. You will have to make architectural changes, or it also come to the death of software entropy. And we want to keep the cost of change low. We want to move it forward downward so we can continue adapting quickly when customers want changes. Because increasing complexity leads to smaller margins. Because when the system becomes more complex, it's harder to understand. And when it's harder to understand, you need to spend more time. And more time means either more people or more longer working hours, which means more salary out of the company, which reduces the margins. So this is something to think about if you want money. On the other side of the aspects, what can managers do? What do they do? I work for a very large software company. I think it was ranked the 5th largest on software revenue alone, Ericsson, with 90,000 developers. And there's a lot of managers there to manage that kind of people, because there's a lot of products. My product alone is 230 people wide. It's roughly around 1 million lines of Erlang functional programming. And what can they do, the managers, when they start noticing, you know what, we want this new functionality, but the teams are saying that this new functionality will take 4 months for one team to get in. What can they do? They can control 2 things. The managers have 2 things to control. It's time or people. Either they can enforce more overtime. Okay, we really need this. You should be working overtime for the next coming 3 weeks to get this in. Or we can hire more people. We will get in a quick response team from some contractor that can give us 10 people, just more people. People. This has been known since at least the 80s or 70s, that adding more people will make it worse. But it is the only thing managers can control. It is a very natural thing. It's a natural response. Because somehow we perceive the complexity as a building project. I just need more people slamming on more bricks and it's going to work. It's going to work out. But that's not going to work at all. And this has been dealt with already in a book called The Mythical Man Month. Anyone who is a manager hasn't read The Mythical Man Month, please read The Mythical Man Month. It's a very good book about just that. Sorry.
It has a new edition.
There's even a new edition. Excellent. So this is not the thing to do. Do not add more people. Because the problem is that the system is already too complex. There's already too much software entropy. What you want to do is to take a break. It's a very counterintuitive thing to take a break and let it go. There was one unit at Ericsson that was in a really bad spot. The whole organization is called DURA. It's DU Radio. And they were in a really bad situation. They were having a high cost of change. We're talking about thousands of people. And they chose to do that, take a break. You know what? We will take control. We will take control back. We will reduce software entropy. We will get our head straight. And they did. And now they're doing something exceptional. They are releasing the software straight out to the customer immediately when they're done. So it's continuous delivery. They took control. They reduce the entropy, because when you have a clean house, you can run fast. That about the economic perspective. What other stuff is there to take account for? The read-write ratio. Studies by Microsoft and IBM shows that on average, large legacy systems, if you're working in those, you have roughly a 1 to 10 to 20, 1 to 20 I wrote here, 1 to 20 ratio between reading and writing code. So if you're going to write one line of code for 1 hour, you have probably been reading code for 20 hours at least. That's the ratio between it. So people that work with maintainability and maintenance tend to spend a lot more time reading and trying to comprehend systems than actually making changes in them. It is because the systems are complex, and complexity requires cognitive effort to understand. This is completely normal. So I work in a large, fairly large product, which has been living for 10 years already. And my working days are very close to this. That doesn't mean that I'm lazy just because I'm not hacking out code for every minute. It means that me and my team, we have a very good understanding of the areas that we will manipulate, because this product is out there already affecting. It's an EType system embedded. If our product fails, it can affect millions of users that cannot make any call anywhere suddenly. Suddenly no one in Köln can make a phone call. That's not acceptable. If I want to make a change, we take the time to comprehend the surrounding context, the complexity. What are we changing? How are we impacting it? And we have to. So complexity is obviously our enemy. I'm nearing the end, and code is a time sponge. I want everyone to maybe just look at my idea here and disagree or agree if you're not, as you wish. I think that code is a necessary evil. I love being a programmer, but I think it's a necessary evil. Because at the moment, code is our only best means of expressing our ideas in a reproducible way as an algorithm for a machine. Who knows what it will be in 200 years? Perhaps we will be having organic computers and we are programming using amino acids. I do not know. But producing code takes time. According to the read-write ratio by the studies, if I write code for 1 hour straight, I've already wasted 20 hours understanding something. I've prepared. It has an overhead. So that code cost already 21 hours. Every time someone like John comes along and reads that code, he has to comprehend it as well. So that code is absorbing time from John as well. The same thing happens if someone else comes along and reads that code. They need to comprehend it. So code are like small points in reality that are absorbing time from everyone all the time. If you're scrolling a page and you see something, what is this? I don't really understand this. It's absorbing you. It's like the Dementors in the Harry Potter movie that are sucking your soul. But you just don't see it. It's happening slowly, going in there. And the sad thing is that this scales. If you work in a large organization, this is happening for everyone that is looking at your code. Everyone that's working on a really large project has a piece of the system that everyone tries to avoid. Like, oh no, I don't want to go in there. That's horrific. Yeah, that laughs. Everyone knows this. Yeah, we have the same thing in our product. Sadly, one portion where you want to stay out of that as much as you can. I've had nightmares thinking. No, of course I haven't had nightmares about that. But it is truly horrific. And before you go in there working in that piece of code, I've seen people do the cross signs and oh my God, okay, please work. And that's because software entropy has gone wild. And no one wants to take ownership of that. So this is happening right now. I probably have colleagues working right now that are being absorbed by code somewhere. Someone is suffering. So think about that. Code is a time sponge. You need to spend a lot of time making it really good so that you free others from that sad destiny of being absorbed by a piece of code. The last thing, quality. I've usually, once in a while, I hear discussion about quality and what is quality, and I think we need to distinguish between internal and external quality. Internal quality is quality that only the developers can see. It's only me when I'm doing the cross sign, oh please don't let me go in and work on that piece of code. Only I am aware about that quality. The customers, they don't even know that exists, because the customer wants telecom grade quality, right? So that's what they see. Internal quality is when the developers, you can perceive that because we can see the software entropy. That's the reality. It's very hard to measure because it's tightly coupled to psychology and cognition. It's something that is in everyone's mind, but if we don't speak to our colleagues, we cannot put words on it. If everyone is suffering in silence and no one is speaking to each other, you know what? Perhaps this piece of code is really bad, but you don't dare to say that because you don't want to offend your colleague, then we cannot see the internal quality. Everything that is coupled to cognition and psychology benefits a lot from speaking. It is our God-given way of communicating is by pushing out air and pushing it against the eardrums of someone else. I think we should be utilizing that a lot more. It's ways of trying to catch this is I'm putting there. You can measure psychomatic complexity, function points. Thank you very much. Are we following a naming scheme? Yes or no? Following a naming scheme doesn't necessarily guarantee that something is good. It just tries to make it more consistent. So it's bad in a consistent way. How many source lines of code do we have? Is this too much? Is it really reasonable that this part of the system that should only be handling transactions is 76,000 lines of code? Do we have a duplication in there? Do we have code coverage? All of these are attempts of giving an indication, because there is not one tool that you can run on source code and it says your internal quality is 0.6 because it's coupled to cognition and psychology. Then we have external quality, which is the flip side of the coin. This is very easy to measure because this is what customers can see. I am a customer of Skype. Well, I don't pay, but I use Skype. And as far as I know, Skype works. Then, of course, I know there is someone suffering behind. There is probably one part of the system that no one wants to touch. But as long as that is working, everything is fine. As far as I'm concerned, external quality of Skype is good. This can be measured by fault reports. How many faults do we find per month? How stable is it? Are we passing all the tests? All of that kind of stuff. Easy to measure. This is also tied to maintainability, because both should be high. You should have a high internal quality and a high external quality. Only having one will not give you a maintainable system. Maybe even the internal quality is a little bit more important to have a highly maintainable system. But if you don't have high external quality, which should be pristine, you cannot have customers. So speed versus quality. There is no real versus. The only way to go fast is to go clean. You need a clean house if you want to be able to run in it. Because internal quality dictates the rate at which you will be able to make changes. If a customer wants a change quickly, your source code needs to allow you, your architecture needs to allow you to do quick changes. If it doesn't allow you, you will be fighting your own system. You will be doing overtime. You will be working harder, not smarter. So just the final here. If we want a system that is easily comprehended, we need a system that's easily comprehended, on both architectural level, how it was designed, and how it's written, implemented, if we want a system that allows us to respond quickly to change. And we need to. Ericsson is a very large player, and there's a lot more customers coming in, and we're always under pressure. And I think everyone is under pressure. Everyone working with systems and software is always under pressure in some way, because that is how it is. It's a jungle out there, and the animal that doesn't run fast enough will be eaten up. And the things that allow us to run quickly is our source code, the way it's organized, the level of software entropy. With that, I'm done. That was questions. So.
Your comment about complexity. You seem to be saying that less code is better than more code?
Not necessarily.
Okay. Well, anyway, I have an example of my favorite APL primitive, which is dyadic iota. I can basically do it in 11 characters, but I've been working on it for 30 years. And the amount of code gets bigger and bigger. But the difference is that the 11-character solution can take you centuries to get a result, whereas after 30 years of work, you can sometimes get it in under a second. So what's your comment about that?
So that would be something pertaining to, so we're talking about performance now.
No, we're talking about complexity.
Okay. But going to maintainability is, the thing with maintainability, it is how maintainable something is how easy can I, a human, make a change. So I cannot comment anything really about the performance, if it's running quicker or not. I would say that if it's easier to understand, I would be happy if we would be working together, I would be happy if you would give me the solution that is easier to comprehend. And if that happens to coincide with a quicker one, then that's really, really nice.
But it doesn't.
It doesn't. And then the only thing that we have to be pragmatic about it, then can you, thank you for, now I clicked here inside my own head. And I want to, there is the fourth law of Lehman is conservation of familiarity. That if you want to be able to maintain a system successfully, you have to conserve the familiarity of the system somehow, the knowledge of it. And what is then important is that you have left that legacy with someone, that knowledge about it. That is the importance, is that if I am the one that is supposed to maintain this, is that I feel the familiarity that you've had with the system. Without that expertise, it's going to be very, very hard to maintain it successfully, because then I might erroneously make a change that will make it simpler to understand, but reduce the performance.
The piece of code that no one wishes to touch, that demands to be rewritten, doesn't it?
Yes, absolutely. That's what has to be done.
I guess when I'm listening to this conversation, I think there's a separation between system complexity and the complexity of the code for an individual function. And the maintainability is more related to the system complexity. And if you have a system where one function or one area nobody wants to go, it's because there's no separation of concerns. It's one piece of code that tries to do everything. And hence it needs to be rewritten. And if I have one little function that fits in a very specific area of the system, it can be very complex, but it doesn't need to be touched. It's a separated piece of concern, and it will continue to live that way. And as long as it does its job, it's got defined input and output, and it works, it will never need to be touched. So I think that the architecture solving the domain issue is perhaps more important than the coding of individual functions. This is my sense.
Can I just make a short comment on that? Absolutely, that's definitely true. The hard thing is knowing beforehand which parts of the systems can live isolated without ever having to be touched again. And since we cannot know that, we need to realize that developers we are the one that probably leave the most legacy after us than anyone. Maybe I think that we are leaving legacy behind us every day. For every keystroke that you are saving and getting into a repository, you're leaving a legacy. And I can never know if someone needs to live with my legacy or not. So the only thing I can do is to try to have the mindset of that I'm just borrowing the earth, the same mindset, but with the code. That I'm just leaving something behind, and I want them to marvel at my legacy when they see it.
So I think something that gets a lot of people when it comes to maintainability is how do you in practice create the necessary social pressures to effect simplicity inside your development process? And the first time that I actually saw somebody achieve this in real software was the clean room software engineering guys, because they required everybody in their development system to prove that their code was correct to a given standard, which forced everybody to simplify everything so that they had a chance of succeeding at that metric at all. And but that required a lot of training. So a lot of companies might not want to do that. In academia, we sort of do that naturally. But in a business setting, do you have a feeling of a process, like some kind of specific process that that developers can use to create the social pressures necessary to create simplicity, rather than being pushed by other things that may appear to be more important at the time?
Yes. Let's see. I have 5 minutes. So I will. I think that there needs to be a balance of power. There needs to be business people that are trying to pressure us, trying to force me to give them what they wanted already yesterday. And there also needs to be the other pressure that us, the developers, are saying, no, forget it. You will have it in 1 year. So we can negotiate and get something that is good in between, that is for the good of the company. Because the business side knows what is important to get the revenue, because the revenue will give me the salary, will give me the chance to exist tomorrow. And I want the company to be preserved and deliver high quality products. As for within the team, I think it's only transparency and being courageous to actually pressure and ask everyone. So very short parenthesis, my team is doing something called mob programming, where we all work on the same thing on the same computer, so we all see everything. And there we have the high bar of being able to always ask why. Why isn't this better? What are you thinking there? And I think it is important to always have someone asking the why. With regular time intervals, we take in someone new. And that person always starts asking the why question. Because we've all sedimented in our ways, and we're all used to that command taking 5 seconds. If someone new comes in and asks, why is that taking 5 seconds? And we are courageous, so we say, actually, we don't know. Let's measure why. And I think it's important to always ask, why isn't this better? I think that could be the, why isn't this better? I hope I answered your question. Yeah?
Yeah, I was just going to ask, because to me there's complexity in 2 levels. There are systems that are complex because the subject matter is complex. And then there are systems that are complex because the coding is a mess. Or it's hard to, we say, maybe the people who manifested the logic didn't have the comprehension of the professional subject at hand. And that can lead to complexity in the code, even if the problem is maybe simple. So do you make that distinction, and how would you see that impact on maintenance, the relation between professional subject and the software development complexity?
Yes, okay, with 2 minutes to go. I think that this is important when talking about the role of the engineer, is that if I can see that with a relatively acceptable cost, I can change, for talking about the architectural complexity, is there something like a domain-specific language that would make this simpler? If I'm working with text processing, could the use of regular expressions make this better? Then that would be the shift of the tool. Perhaps, there are, of course, matters that are complex, that are so complex, no matter what I do, perhaps it's gonna remain hard. So I think that's the importance. It's the role of the engineer, if we can succeed in using the right tool and the right environments to create the simplicity. It's a very hard thing to, yeah.
I don't really have a question, but I have a comment. I have a personal ideal for writing code or making the code readable is, can I debug the code by reading it if my life depended on it?
That's a very good thing. I think you should take that to heart.
It's an ideal, but
yeah,
something to try for.
It should be like that, I think. We should always be able to comprehend it. Very good.
Gianfranco, that was humbling for me. I'm guilty of all of the negative things you said. So I will try to do harder. So thank you so much for a wonderful.